Hey, afternoon, folks. This time around, we are moving through directed numbers and algebraic expressions in Form 1 series. Let's have a look at what we have there. We want to understand the use of a number line to represent directed numbers, perform operations on directed numbers. When we say operations, this is addition, subtraction, multiplication, division, you name it. We also want to identify and simplify directed algebraic terms and also substitution to find the value of algebraic expressions. So terms that we are going to find are familiar are directed number, positive number, negative number, number line, algebraic term, coefficient, variable, substitution. Right, the number line is designed to increase to the right and decrease to the left. Zero is the neutral point or the center. Positive numbers are to the right of zero and negative to the left of zero. So in example there, we are given -3. It means we move 3 steps to the left from point 0, which does not carry a sign. When we say +5, similarly, it's 5 steps to the right from point 0. Then operations that we are going to be performing addition. This is moving to the right. If the signs are the same, I mean, the sign is maintained and there is an increment. When we have different signs, this is more like subtraction. So the bigger sign, the value with the bigger sign is maintained. Multiplication and division, same signs, they give us a positive result. Different signs are negative. Right. Algebraic terms, they include a number, which is a coefficient, that's a number multiplying a letter. Well, the letter we refer to it as a variable. Then a sign, positive or negative. They are examples of um, uh, expressions, and these ones, they just made up of coefficient, variable, and the sign. Well, substitution means replacing a letter with a given value, then calculating the result. So there we are going to quickly go through examples together. Right. First one, we are required to locate -4 on the number line. So like we were saying, somewhere neutral, we have 0. So it's negative. It's going to be 1, 2, 3, 4 to the left. So it's -1, -2, -3, -4. So it means this is the point where we have -4. Then example 2, we are interested in an evaluation. There we want to evaluate -3 plus -6. So the sign is maintained. Our result is going to be negative. Then is 6 plus 3, that's 9. Then moving on, we want to evaluate. So here the signs are different. So our result is going to maintain the sign on the bigger value. So when we add the, which is more like the difference is 3. So that will be -3. Then moving on, we want to evaluate -4, -6. So the signs are the same. So the sign will be maintained. Or in other words, from -4, we are moving 6 steps to the left. So that will be -10. Then the next one is a product. When it's a product, we are multiplying -3 and +5. So our signs are different. So our result obviously is going to be negative. 3 times 5, it gives us 15. Then example 6, this is division and our signs are the same. So our result is going to be positive. When the sign is positive, we don't write it. So it's good as 12 divided by 3 to give us +4. Then next we have negative 2x plus 5x. So here we are now having algebraic expressions. Our variable is x and it's the same power. So we say these are like terms. So the negative is on the smaller side. So it means our result is going to be positive. So it's positive. We look at the difference between 5 and 3. I mean 5 and 2, that's 3. Then because it's in terms of x, have it as 3x. Then number 8, we have 6a minus 9a. These are again algebraic expressions, all in terms of a. And if we check 6 and 9, the bigger value has got a negative, so our result will be negative. Now, difference between 6 and 9, that will be 3, so it's -3a. Then moving to substitution, we're interested in finding the value of 3x when x is -4. So we're going to say equal to 3. So we multiply by whatever value that x takes. When it's negative, it's important to surround it by brackets. So we are multiplying negative and positive. Our result will be negative. 3 times 4, it gives us 12. Then finally, on the 10th, we also want to do a substitution and evaluation. So this will be equal to is minus 5, then we multiply by whichever value that y takes. For this case is 2 plus 7. So if we say minus 5 times positive 2 gives us negative 5 times 2, which is 10 plus 7. Now we are summing negative and positive, but the negative sign is on the bigger value, which means our result is going to be negative. Then we look at the difference between 7 and 10 is actually 3. That's our solution. I hope you guys you found it informing for the first part of directed numbers as well as substitution in the formula. Thank you.